Hello and welcome to 1.7. We're on our last section here. And this one here is about interval notation. And some of the notation is different than what you've learned in the past. So we're using a new notation because that's probably what you're going to see in college. So you should have 1.7 out and we're working on inequalities. And here we go. Okay, we're using a new interval notation. That's what I talked about. We're going to talk about intersection and union, how to solve a linear inequality, how to recognize ones with no solutions and all solutions, compound inequalities, so there's more than one, and then absolute value. All right, when you go down here, when this has parentheses, that means it's an open interval. It does not include the A. So when you were littler, you used open circles here, is what you had. All right, when you were on a number line, you would have used an open circle. All right, instead of open circles, we're going to use parentheses. So let's say A represents 7 and B represents 200. You have an open parenthesis that means it can be as close to 7 as it wants to be, but it cannot equal 7. And it's everything in between. The brackets are like the closed circles you used to use. So on your numbers, if it includes this, so it can equal A and it can equal B is what that means. It can get close to and equal to. Okay, infinity is a concept, so it never has a bracket. It only has a parenthesis. If it's greater than only, that means it cannot equal A. It has to be bigger than A, so it doesn't include A, but then it's everything bigger than A or greater than A. And now if it can equal B, and it's infinity, but it's everything less than, so it can equal B, that's a bracket, then everything less than B is negative infinity. All right, let's try this with some numbers so it makes a little more sense. I'm going to do mine and you're going to do yours. So we're going to say we're going to write this in set builder notation also, which I'll talk about here. So let's go 1, 2, 3, 4, 5. So 5.6 is right there, we're going to say. Hopefully, it will draw. Okay, now this means it cannot equal 1. So it's a parenthesis. It can be 1.00001. It just can't equal 1. And then it can go up to 5.6, and it can equal 5.6. All right, so it can't equal 1. It can equal 5.6. So we have a parenthesis and a brace, and it goes like so. So that means all numbers between 1 and 5.6. Set builder notation, remember, is your brace, and it goes x such that, or any variable you want, such that 1 is less than x, and x is less than or equal to 5.6. So if you read this way, x is greater than 1, which is what we got, and it's less than 5.6, but it can equal 5.6, so we have the equal sign here. Pause and try yours. You should have only had a 7 on your number line, and then an infinity. Then set builder notation is x such that x is greater than or equal to 7. So it's all numbers greater than or equal to 7. All right, now we're going to look where they overlap and where the entire number is. Okay, intersection, the symbol for intersection is like an upside down U. That's what they have in common, so it's in both sets. Union is just a U, and that is what everything is. So it can be in one set, the other set, or both sets. So here I want to find intersection and union. So let's work on intersection first. So let's draw 5 and 9 out. So we got 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 5 is inclusive, so I have a bracket. 9 is inclusive, so I have another bracket, and it's between 5 and 9. So that represents that first set there. Let's change colors here. Now my second set is 6, not inclusive, so it's a parenthesis, and it goes to 15, not inclusive, so it's a parenthesis. And all of that is this second set. Intersection is what they have in common. So where do you see a black and a red line? So what they have in common is between 6 and 9. But we have to be careful because it does not include the 6, because that's an open parenthesis, but it does include the 9 because that's a closed bracket. All right, now we're going to do union. So union is where does it start and where does it end? And this thing starts at 5 and goes through 15. It's everything, wherever you see a line at all. So 5 is inclusive, so we have a bracket all the way through 15, but it does not include 15. Okay, pause and try yours. Okay, let's look here. We have -2, -1, 0, 1, 4, 5, and 6. So it starts at -2 inclusive. It goes to 1, not inclusive, and it includes all of those. The next one starts at 0, not including 0, goes to 6, does include 6, and it's here. Okay, so now let's look at our intersection. And our intersection is where you have both lines, is what they have in common. Well, it starts at 0, but not including it, and it goes to 1. That's where you see the red and the blue line. Both parentheses, because it doesn't include 0 or 1. Now let's look at union. Union, my graph starts at -2, and it goes all the way to 6, and it includes -2 and 6. All right, now let's solve and graph. That's just linear, so not too much. So we're going to subtract the 2. Remember, your job is to get the x by itself. So you have -3x is less than 3. All right. What happens when you divide by a negative? Do you remember? Hope you're saying, yeah, I got to split that sign. So it goes from a less than to a greater than, -1. So all we need on our graph is a -1. It's not inclusive, so it's a parenthesis. It's greater than going this way. If I asked you to write in set builder, you would do x such that x is greater than -1. All right, let's go down here. Okay, try yours. Let's see what you get here. So you should have said 3x plus 12 is greater than 3x plus 1. And you're looking and say, hey, that looks weird, and you're right. Because if I subtract the 3x, the x's go away, and I got 12 is greater than 1. When is that true? The answer is always, remember? This is one of your identities, and it's the entire number line. In set builder notation, it looks like this. X such that -infinity is less than x, which is less than infinity. It's everything. Okay, how did you do on the next one? You had 5x plus 20. It's greater than 5x plus 31. Well, subtract the 5x's and we run into the same problem. But this time we say 20 is greater than 31. This is not true. This is the empty set. There is no solution. Remember, this guy is inconsistent. Oops, sorry about that. Let's go back up here. All right. This here's a compound inequality. I'd like you to try it just to see if you know what to do. Okay, the first thing you should do, we got to get x by itself, but we have two inequalities to work. That means when I subtract 3, I have to subtract it from both of these sides. So now you have -2 is less than or equal to 2x is less than 8. Divide by 2, but I must divide everybody. -1 less than or equal to x less than 4. Okay, when you're doing this one, -1 is here. It is inclusive because there's an equal sign. And if you read it this way, it's x is greater than. Then if we put a 4 here, that's not inclusive because there's no equal sign. So it looks like this. Your set builder notation is simply x such that -1 is less than or equal to x is less than 4. Nicely done. Okay, absolute value, and there's a typo on this one. We know that if it's less than, the value is going to be between the negative and the positive of this value. If it's greater than, x is going to be less than the negative value. This should have a negative right there. And greater than the positive value. and we'll show you what this does. Okay, let's do this one together, and then I think you get to play. All right, first thing to solve is this thing is written wrong. Like, who ever did this is crazy, but your book does it too. Remember to switch this, because this is greater than 18. Okay, you have to do the positive and the negative value. So the positive, you just write it as is. So 6 minus 3x is greater than 18. The negative value is 6 minus 3x, but when I add a negative 18, I have to flip my sign, because that's like dividing by a negative 1. Now solve them both. Subtract your 6's. So negative 3x is greater than 12. Divide by a negative 3. Remember, you're dividing by a negative, so you have to flip that to a less than. Negative 4. Same thing over here. Subtract your 6. So negative 3x is less than a negative 24. Divide by your negative 3. Flip your sign, so x is greater than 8. Well, if we put a negative 4 here and less than, so that's not inclusive because there's no equal to, then we have an 8 on our graph, not inclusive. See how that's an OR graph? It goes out. Okay, to write this here in set build, you can just do this, x such that x is less than negative 4 or x is greater than 8. Don't forget your braces. Nicely done. Okay, try yours. Okay, it was written right, so your first step should have been just to write it down. Less than 15. Now remember, when you do your negative one, you never change what's in here. Those signs never change. You flip the sign and change the answer only. Okay, subtract your 8. So 3x is less than 7. So x is less than 7/3. Nothing flips because we did not divide by a negative. Subtract your 8. So 3x is greater than a negative 23. Divide by 3. You do not flip again. All right, so we got a negative 23/3 here going in this direction. We have a 7/3. I don't really care where you put them on the number line. Also not inclusive. This is an AND graph, which we knew because it was a less than. So when you write this in set builder, such that x is in between these now, right? Negative 23/3 is less than the x, which is less than the 7/3. Come on, right, there it goes. All right, good luck on your homework. I hope you do well. Make sure you're posted on the discussion boards.